Hi guys, I'm Marian, and today we're gonna talk about the states of matter, solids, liquids, and gases as the last video, but in details, in specific details. Okay, now let's start with the solid. Like you said in the last video, that solids are really close together, and the attraction force between the particles is very strong, and it has a different shape and a different volume. And you took an example about a skateboard that if you move when it's from one location to another, it will not change in size, and it will not change in size or shape, and it has a definite shape and definite volume, and it has a um, strong attraction force between the particles, and they move only back and forth. So today also, when we say this again, that it doesn't move it doesn't move a lot, it moves only back and forth, and its attraction force is very close. Now there is two kinds of solids: crystalline and amorphous. Crystalline and amorphous, two kinds: crystalline and amorphous. These two kinds, what does makes them different? Crystalline is the type of solid that the particles in the solid are arranged in a regular repeating order. Regular repeating order. In the crystalline, the particles are arranged in a regular repeating order. And that's what makes it different from amorphous. Amorphous is arranged in a random way. It's arranged in a random way, and it doesn't matter. It's like, not it doesn't matter. It doesn't have a repeating order. It's just randomly arranged. But crystalline is arranged in a um, a specific repeating order, regular repeating order. That's the difference. But the shape, the same. They have no different shape and no different volume. Let's take an example of um, crystalline. Let's take example diamond. Diamond is an example of crystalline, and let's take an example of amorphous. Example of amorphous is charcoal. Charcoal is an example of amorphous, and diamond is an example of crystalline. And what makes them different also, the arrangement of particles. The arrangement of particles also makes them different, and like when you touch it, in the strength. That's why diamond is very strong, and charcoal is very brittle. Now let's talk about liquids in detail this time. We said last video that liquids move move faster than solids, and the space between the particles more um, is less is more than the space between the particles is greater than the ones in solid, and the attraction force between the particles is weaker than the ones in solids, and they move in everywhere, every direction, and they have definite volume but no definite shape. Now also they have also something called viscosity. Viscosity is uh, the measurement of a liquid, liquid's resistance to flow. Measurement of a liquid's resistance to flow. Like, let's take an example. Honey. When you pour honey, and like you put it in like in your, like when you take a spoon and eat some honey, and when you drink or you pour water, who moves faster? Of course the water. Why? Because it has less viscosity. Viscosity depends on the shape and and the size of the particle. It depends on the shape and size of the particle, and also it depends on the attraction force between the particles. The attraction force between the particles of honey is more than the attraction force between the particles of water, but not that strong as the ones in a solid. Now, if you see here, this liquid has a high viscosity, low viscosity, I mean. This liquid now, when I freeze it, this liquid has a low viscosity. Uh, the viscosity, the shape and the shape and the size of the particles. Viscosity depends on the shape and the size of the particles. Honey, the liquids that have like big particles have a difficulty in slipping past one another. That what lets water to move faster, or liquids to move more than solids. Yeah, and another thing that it is that in liquids there is something called surface tension. Surface tension is the uneven forces acting on the surface of a liquid, on the particles on the surface of a liquid. The surface tension is the uneven force acting on the surface of a liquid. The surface tension is like particles under the surface of a water have water particles surrounding it everywhere, so it's attracted uh, from all directions, and it moves in all directions. But the liquids on the particles on the surface don't have particles above them. So they're not. So they experience a greater experience. That is the down pulling of the particles. That what makes surface tension. Now let's go to and yeah, surface tension. Before we go to gases, surface tension, what makes the spider walk, that enables this small, there's a kind of small spiders can walk on the water because of the surface tension, but we cannot walk on the water because our mass is greater than the surface tension can hold. But small spiders can walk on water because of surface tension. Now let's go to gases. Gases, we said the last video that gases don't have a definite shape or definite volume, and the attraction force between the particles is weak, or is very weak, very weak, or even absent. It is even absent. Yes, absent. And they move in all directions, and they they are the most speed between solids, liquids, and gases. Now let's see the difference. See the difference now. This is a gas. Now this is a liquid, and this is a solid. See the difference between solid, gas, solid, and the gas, and the liquid, and the gas. The distance between the particles is very great in gases, greater than the one in solids and liquids, and gases do not have definite shape or volume. But in liquid, I forgot to tell you something. In liquids, it can take the shape of its container. When it doesn't have a definite shape, and that what lets it to take the shape of its container. Now let's go back to gases. The particles in gases move very fast, and they pump, or they hit each other, and what changes its speeds and direction. Now let's go to the forces. The forces is very weak or absent. That's what I said. And now let's go to the vapor of gases. Gases. The term vapor comes from that vapor, a liquid that or a gas vapor. Vapor is a material that is gas. Now it's a gas, but it is in room temperature a solid or a liquid. Like if something is a solid or a liquid at room temperature, solid or liquid at room temperature, such as like water is at room temperature a liquid, and glass is at room temperature a solid. If it if we transfer it into a gas, it is called vapor, such as water vapor, which is the vapor of the water in liquid, which is the vapor of the water, which is a liquid at room temperature. When it becomes a gas, it is called water vapor. And other substances that can make a vapor, such as rubbing alcohol, iodine, mercury, and gasoline, and also metals, and like everything that is solid or liquid. And we can make it a gas, solid or a liquid at room temperature, and we can make it a gas when we let its temperature go high, is called a vapor when it's in a gas state. And yeah, that was all for today. And don't forget to like and subscribe and share, and share and put a nice comment. And next video we're gonna take uh, uh, the yeah the uh, the pressure the changes in pressure can affect the states of matter. And see you later. Bye.